Bismillahirrahmanirrahim. Assalamu alaikum students, welcome back. October 2022 and variant 42 and paper 4 mechanics. So let's start. First question, a cyclist is riding a bicycle using straight road AB length 50 meters. Cyclist starts from rest A, reach speed is this B. Cyclists produce a constant driving force of 100 newtons and there is a friction force against work done, against friction, sorry, is from A to B is given is this much. Find total mass of cyclist. So let's start. Make some rough idea. Data must write, okay. Speed start from rest. So speed is here is 0. And at B speed is 6. And driving force is given 100 newtons. And work done by friction force 3560. And we need to find distance is given 50 meters, you can see from top. And we need to find out the mass. Okay, now what is the plan? What data mentioned here? So how we can start the question? First of all, we have to look upon the data is u given 0. Using this data, we can find acceleration. Normally formula in this situation when driving force is given, so when we use this formula, net force equals to ma. So whenever you don't know what to do, apply this formula, and now you can see applied force minus frictional force equals to ma. Problem is here, applied force we have, okay, I can plug in 100 newtons. Friction force I don't have, but we can find from here. How come? Work done by frictional force is formula friction force into distance. This given by him is 3560. Friction force unknown, distance is 50 meters. If I divide this friction force to 3560 and divide by 50, and answer is coming with us 71 newtons, 71.2 newtons unknown. But again, I stuck. I don't know how to find acceleration. So data is enough given here. So 2as is equals to v squared minus u squared. And a is unknown, s is 50. Last velocity is this one, which is 0. So acceleration we can find from here, 6 squared 36 divided by 100. And we got 0.36. So this acceleration I can plug in here. I hope so you got a way that how to handle the question. So whenever you don't know what to do, at least apply the formula and try to check it how we can continue. Okay, let me type in calculator. So mass is becoming 80 kilograms. So I hope so the concept is very clear. Question number 2, particle of mass is given here 0.4. Limiting equilibrium means very clear, acceleration 0, and theta is given 30 degrees. All right, so lie this one, and angle is here 30 degrees, and no applied force is acting anywhere. So it means this situation is what we have. Mass is 0.4, this into 10 into 10. So weight become 4 newtons. And this is for sure 4 sine 30. Because no force applicable here is just placed on the surface. So it is not moving at all, about to move this way because he said equilibrium. So friction 100% backwards. We can say that net force equals to ma, 4 sine 30 minus friction equals to ma. A is 0. So I got a friction force goes there. So F is equals to, and sine 30 is half. So I got 2. Now, how to get this? So all of you familiar, this is a, we need to find coefficient friction. So upward force is R and downward force is 4 cos 30. So this value, so I'm going to apply now here. F is equals to mu R. F is 2, mu is unknown, and R is given by him is equal 4 cos 30. So whenever, so I think 2 divided by 4 times 2 cos 30. And if we type in calculator, so mu value, this goes down under it, and mu value is root 3 over 3, which is proved. So Alhamdulillah Rabbil Alameen. Okay, I hope so. Idea is clear. Uh, Next part, we say the force of magnitude. This is now applied. The force means this 70 is now applied B directly up. Okay, first it was no force was acting, but now force is acting. Okay, this angle is 30 degree and mass is here placed and force of what 7.2 newtons acting. P is given that P is at rest. Rest means very again it is a, it means again still acceleration 0 and find the time and find the time taken from move. Sorry, start from rest. Sorry, means start from rest. So start from rest means starting speed 0. I thought it is at rest. Okay, and the P is moving 1 meter above. So let's say it was first here. It moves there. It moves one distance. How much? S is equal to 1 meters. Okay. And you know, data is very given, clear. U is 0 and S is 1 meter. And what is my target? It's traveling. Okay. And he says very clearly that find out what time. Time is my task. And I think if I get my acceleration from here, I can get the answer easily. So how to find acceleration? So naturally, friction is acting downwards and weight component. What is a mass? Mass is given here 0.4 into 10, 4 newtons, so 4 sine 30. I can see here net force equals to MA because moving upwards. So this minus this minus this. So I can say 7.2 minus friction minus 4 sine 30 equal to MA. But thing is, what is a friction force? F is mu R. Mu is root 3 over 3, and R, we know it is coming 4 cos 30. So if I type in calculator, so it is coming root 3 divided by 3 and times to 4 times to cos 30. It is giving me friction force sharp 2. Although no need to find it because we already found here, but I just want to show you that it coming same. Why same? Because mass is not changing, mu is not changing, so this is same. So next time, if you don't show this working even, no issue at all, simple take friction force same. So 7.2 minus 2 equals 2, this is sine 30 half, we got 2 and 0.48. So when we find it, 7.2 minus 4 and divide by 0.4, and we getting acceleration is equals to 8. Now I can find easily S is equal to ut plus half at square, and we are looking for what? We are looking for looking for time, but acceleration got it half 80 square. S is given by him as 1 meter, u0, and acceleration is 8 and time is unknown. So this is 4 and yeah, this is becoming 4. 4 goes there, become 1 over 4. When you take a root, so time becomes half. Thank you. So Alhamdulillah Rabbil Alameen. I hope so. You got a point clear. Question number 3, he mentioned the question here. Point 3 mass is held at the rest, and a string is attached on angle 60 degree above with the ceiling, and one string attached with a wall. You can see tension in the ceiling is given 4. And let me tell you, when a particle hanging this way, students, a mass hanging here, the tension always like this. Okay, so if in the same situation, tension will be always, because this weight hanging here, tension will go this way and tension will go this way, always away from the weight. So now look at here, and what is this tension? 4 newtons, and this is T unknown, and this mass 0.3, what is weight acting downwards? 3 newtons. I can make a force component breaking. This is so this force is acting this way. So it has 2 components. One is this alpha. You know, when 2 lines are parallel to each other, a line cut. If this is alpha, this is also alpha. So that is why this also alpha. So I hope so you got the point clear. And if this is alpha, so this becomes T cos, and this becomes T sin alpha. Same way is a force Newton acting here. So one force acting this way and one force acting this way, because this arrow goes this way. 660, the 60 is confirmed. So this 4 cos 60 is a 4 sin 60. We can use Lemmy's rule as well, but I think this idea is clear. Now we have to make the components. So it's very clear, this right foot force equal to left foot force. So T sine alpha equal to 4 cos 60. And these two forces equal to the above force. So I can say here T cos alpha and plus 3 equals to 4 sine 60. I repeat, these two forces acting downwards and this upwards. So it means this clear idea. Now I will bring T on the other end. Okay. So this T cos alpha equal to 4 sine 60 and minus 3. You know, this cos and this sine. So this equation number 1, this equation number 2. I know sine up, cos down become tan. So 1 divided by 2. So T sine alpha, keep it up. And T cos alpha, keep it down. And I hope so the point is very clear. This tension cancel, sine over cos give you tan alpha. And 4 cos 60 over 4 sine 60 minus 3. So in this way, I can find alpha. If tan goes there and tan inverse, I can calculate easily alpha value. So I am typing in calculators tan inverse. In the numerator, we have a 4 times 2 cos 60. And in denominator, 4 times 2 sine 60 and minus 3. Answer is coming with us 76.9. Okay, and we'll make sure that this one 9. So I should not 9. It is actually 9, 3, 5, 7. Okay, so why I use this 4dp, one logic behind it. You will use this value there or here. I will use long way like 4dp values value. So I'm using it here. So T sine 76.9357 equal to 4 cos. So I'm putting in 1. So this whole thing will divide. So T is equal to 4 cos 60 divided by sine, in the bracket 76.9357. So I type in calculator and tension is becoming 2.05 newtons. So I hope so. The point is very clear. Question number four, a car of the mass is 1200 kilograms is traveling along a straight horizontal road AB. Okay, and there is a constant friction is a 500 newtons. All right, and so let's make a small type. Or first we read it properly. Speed a point at A, speed is 15. So speed at A 15 and acceleration at A is point 0.8. And friction force to out is a 500 Newton and mass is given by him is 1200 kilograms. We need to find power at A. Power at A. At A means a net force equals to MA. And what is the formula? Applied force minus friction force equals to MA. But power is a concern and power formula, F times 2V. So if I bring this velocity down, sorry, this velocity down, so I get a F is equal to power by V. This formula I'm going to use here. So power by V minus friction force equals to MA. Power is unknown, velocity given at A 15. Friction force is 500 and the car acceleration mass is 1200 and acceleration is given zero point 0.8. So P by 15, so 1200 times to 0.8 and plus 500 because it goes there. And now 15 will multiply and as 15 will multiply, so what I'm typing in calculator, so answer is coming. Power is 21900 watt. Or you can write to 1.33 jump 123 21.9 kilowatt. I hope so. This part is clear. The car continues to move on a power from it, the power, same power to the same power. So what it got it before, and from A to B. And power is applicable. He's saying the car takes 53 seconds to travel from A to B. So A to B, okay, A speed at A to B. He mentions clearly at speed at A is we just got 15 before, and at B is 32. And further, he's saying it takes time. How much? 53 seconds. Time involvement and power. So whenever this equation comes and distance is, we have to show. So work done, what's the power formula? Power formula, work done by time. If you remember, so power is 21900 and work done I can find from here, time 53. So work done by applied force is 219 into 53. In this way, we can find it. Now, question comes in our mind: why we are doing this kind of thing? So answer is coming 1160700. And first of all, we can't use equation of motions because power involved here. And second number, the it is the speed is changing. So let's see how we can apply it and what is a we normally use a special formula. It's called magic formula. Work done by applied force, work done by friction force, kinetic energy plus potential energy at the end point, and kinetic energy plus potential at a starting point here, ending point here. But you know it very well, students, because you know it very well. We know it. Potential energy at both particles have same height, so they cancel out. So not a big trouble. So work done by driving force, we just got it 1160700. And work done by friction force, we have it already, and that is wait a minute. Friction force given 500, but I can apply distance. You know what is formula? You know F into D, small f into D. So small f is a 500, and I can use it. And distance is given by him. Oh, distance is a unknown. And kinetic energy is what half mv squared. Mass is we just got it. Sorry, given by 1200. Velocity at B is 32. And same story here, 1200 and 15 to power 2. So I'm typing the right side first of all. So 600 times to 32 to power 2 and minus 600 times to 15 to power 2. The right side is coming 479400, and this is a 1160,700 minus 500 times to D. So I will bring it this side and this side and then divide by 500. So let's see what answer 1160,700 minus this answer and divided by 500. And distance is proved here 13, yes, approved 1362.6 meters, approved. I hope so you understood the logic. Let's now come to question number 5. And what question number 5 is? According to question, let's read the question. Mass is of block A is 80 and joined with a taut rope. And he mentioned 20-degree angle. Okay, a force of 500 acting on 15-degree angle. Okay, and block moves up. There is a friction force acting B is 50 newtons. So I just mentioned here. And no friction acting on A. All right. And find acceleration and tension of the rope. So let's start. Whenever this kind of question, so first of all, force resolving. So this one force parallel to x-axis and one parallel to y-axis. Because it's 15 angle, so this angle 15. If this 15, so this becomes 500 sine 500 cos 15. When angle given, always cos, and when angle there, angle not given is sine. So this is sine 15. Okay. Now, according to current situation, what is the mass? 80. Mass is 80, so weight become 800. And this is a weight acting downwards. This is 800 sine 20. And what about this? This mass 40 into 10, 400. 400 sine 20. Okay. I think this is clear, and all of you know whenever there's a tension, the rope is the tension towards pulley for tension toward each other. Sorry, tension towards each other always equals to each other because same string, same string. Okay, I hope so. You understood how I resolve all forces. So on a particle, how many force acting? This one, this one, and one tension. And B particle tension, friction force, and weight component. So I will make a two equations. Get ready for A. Basic formula: net force equals to ma, because system is moving upward. Okay, and so I can say 500 cos 15 minus tension minus 800 sine 20 equals to mass is 80 and acceleration is A. Make sure I will take all forces acting on A, not B. So acting is a weight component and tension and this one, three forces acting. Now I can solve this and this together and keep tension here alone, or tension goes there, no problem at all. If tension goes there, so TE plus ATA, and these two values I'm going to type in calculator. So 500 times 2 cos 15 degree and minus 800 times to sine 20 degree. And yes, it is coming with me 209.3468. Equation 1 done. Now I'm going to make it for B particle. So B particle, because again it's going upwards, so tension, these three forces acting on it. So again, net force equal to MA. I can say tension minus 50 minus 400 sine 20 equal to MA, mass the 40A unknown. So now again, I just keep it here, tension and 40 acceleration come here. So minus 40A, and this both component will go there. So 50 plus 400 times to sine 20. And it's going there 186.8081. Question number two done. Now just solve it. This equation, I make it copy and I bring it here and paste. So we can see here, I'm bringing here equation number one and just matter of solving. Sign changes. This will cancel out and I get here negative 40, negative 80 will become negative 128. And from here, 269.3468. So when I come get it, negative 82.5387 and divided by 120. So I'm getting answer of acceleration 0.68. 1 minute, let me recheck. Maybe typing that error is there. Okay, maybe some typing error is there. So let's find it. Yes, student, this is a look like 6, but it's not a 60 actually. This is a mistake only. Rest all okay. So it means this is number is coming with us is one after subtracting 22 negative 22.538. And when you divide this, acceleration becoming 0.188 meter per second square. I hope so. The point is very clear. Now I'm going to plug in this value in any one equation. So I'm going to plug in this in air equation. So it means put in one. When I put in one, tension plus 80 times 2, 0.188 and 209.3468. So it will go and subtract from there. And so let's see 209.3468 and minus 80 times 2.188. So answer is coming with us. Tension is 194.3. So ultimately 194 newtons is of tension. Next part is asking find time taken for the block to reach the speed of this one. So starting from rest U0, last velocity 1.2, acceleration I got just now 0.188, and time is our target. So V equal to U plus 80 and last velocity 1.2 U0, 0.188 and T. So this will go down. Alhamdulillah Rabbil Alameen. I think so. Okay. I'm typing in calculator. So it is coming. Time is becomes what? Time becomes 6.3838 seconds. Okay. 382. So Alhamdulillah Rabbil Alameen. I hope so. So the idea is very, very clear. Okay, let's go for next question, number 6. Number 6, 3 particles ABC of mass 0.3, 0.4, and m kilograms. Okay. And so 3 mass given and a straight smooth table, smooth plane, so no friction. Okay. And distance between BC is what 2.1. A is projected towards B with speed of 2. Okay, and after A collides with the B speed that reduces this one. So it means there's two ideas, so before collision and after collision. So mass is given here is a 0.3 kilograms and here 0.4 kilograms. Okay, this is a particle, this is a B particle. So have a look now. So this is very clear. And this before collision, after collision. So this speed is already we have is V is equals to what speed is 2. 8 on 2. B velocity is, so I'm writing here, not I'm writing here U, starting speed, and this is a starting speed 0. Okay, finally, the velocity of A particle become 0.6 because he said and we need to find out the velocity of this one. So what is the formula? You know it always. M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. So before collision, after collision, momentum always remains same. So zero point 0.3 times to 2, and here 0 because 0 something is 0, and zero point 0.6 times 2.3, and here zero point 0.4 times 2 V. So what happens? This is a zero point 0.6, and this is a 0.3, 0.18, because zero point 0.6 and 2.3, it becoming 0.18 and 0.4 V. So when I subtract this one and divide by zero point 0.4, an answer becoming finally is coming what he was demanding from us. V is coming 1.0 meter per second proved. So Alhamdulillah Rabbil Alameen, that's 2 marks we gain. Next part, after collision A and B moves directly towards C. Okay, and particle B now collide with C, all right. And after collision, the two particles coalesce and have a combined velocity of 0.05. So have a look before collision and after collision. So let's talk about, because there are two particles, B and C. One is B and one is C, B and C. But after they will behave not together. They will behave as a one particle. And I will deal as a one object. So this B and C, okay. And this velocity of B will behave as a starting velocity, and this is point 3, this M, this point 3, and this M. Let me check. Yeah, no, sorry, point 4. This is a point 4, and this point 4, and this point is M mass. Okay. Further, you know that starting speed of B will hit the it will move is B with after collision 1.05. So there's a 1.05, whereas this velocity is 0, and after that they move in a with the same velocity 0.5. So combined velocity 0.5. And what is the formula, student? M1 U1 plus M2 U2 is equals to M1 V1 plus M2 V2. But because velocity is same, so I will take because if I take a velocity same, for example, like that. So take common out velocity and mass will stay in bracket. So it will behave like this: M1 M2 and times 2 V. Now plug in the values: mass 0.4 times 2 1.05, and this is 0, and there's a zero point 0.4 plus M and 0.5. This is and this 0.5 will divide, so 0.4 into 1.05 over 0.5, so 0.4 plus M, and this will subtract now. So 0.4 into 1.05 over 0.5 minus 0.4 will give us mass. And now I'm typing in calculator. So 0.4 into 1.05 in denominator 0.5 and minus 0.4. So Alhamdulillah Rabbil Alameen. So mass is becoming 0.44 kilograms. Done. So let's go for the next part, C. Find the time taken. Time it takes from instant. Instant means time when BC collide. Okay, when BC collide, this is very important here thing, until A collide with combined particle. Okay, until A collide with a combined. So I think this question will create trouble. So best technique, I will make what? I'll make these 3 diagrams. Okay, 3 or 4 diagrams I have to make it to have a proper idea. This A, this B, and this C. This A, B, C. maybe 3 or maybe 4. I'll check how many diagrams are required. Maybe because these diagrams are very important to understand. Otherwise, we will not understand the concept. Anyway, in the beginning, and BC is a BC distance is given by him is BC only 2.1, 2.1, 2.1. So make sure this is a S is equal to 2.1. S is 2.1 meter from B till C. In the beginning, A particle is here, and B particle is here, and C particle is here. Okay, it comes and hit. Okay, so when hit, okay, they both particles is now at this moment BC. This is saying that when they collide, the stopwatch on here. From here, I will start counting, and then B will go there. C is still there, still not moving at all. And then this is a wait a minute. BC. So I should not wait a minute, please. Did he mention a part position? No. So I think this is a just only uh, like not a position, just a positions only. I can't label it. Anyway, all right. So now situation is even I erase this one even eight. Okay. So now A is here and B is here. Hmm. Now afterwards, what happens? Speed of the A at this moment is is 0.6. So I think we have to make it here. The velocity is here 0.6. And velocity here, I got it just now 1.05 velocity. Okay, now it is just after hitting. Okay, then it will travel towards the interesting part. What is what the particle B? How much time will take a B particle to C? So I'm writing here time for B to C. I'm going to target and find time, and you know it very well. Let's find it. The time we know it distance is from B to C is 2.1 meters. You know already. So what is the speed of B particle? Velocity speed is 1.05 meter per second. So what is formula? Because there's no friction is there. So no acceleration is there, nothing. It will move with constant speed. Okay. So what is formula? Distance is equal to speed into time, V into T. So S is equal to VT. Okay. So distance is 2.1, V is 1.02, and time. So this will go down and time. So time becomes 2.1 over 1.05, and time becomes 2 seconds. So it means this. How much time B will take to reach C is a 2 second. This is very important to know it. What is the reason? I just go discuss with you what is the logic behind it. So it means B will take how much time to reach this C is a 0.2 second, so 2 seconds short. Uh, because problem is that we must know that uh, BC collides. He said BC collide. Hmm? So BC collide here, and time when it will collide, this time 2 seconds is very helpful for us. Reason when B will travel in reach C 2 seconds, so A will also move in that time 2 seconds. Okay, so I'm talking about how much distance traveled by the A particle. So for A particle, how much it will move after collision. Okay, after collision, how much it moves. So let's start. Because S is equal to Vt, and what is the velocity of A is zero point 0.6. So zero point 0.6 into 2. Why? And actually, I want to know that when B travel to C, how much A has reached, how much A has traveled. That point is very important to us to know it. And that is a 1.2 meters. It means this A will travel point. So let's go show you that A is here first. A traveled from here, and how much A traveled? This A traveled 1.2 meters. Okay, and whereas in that 2 seconds. Okay, And how much left behind? It means A is at current this situation now. Here. A is here. Okay. And how much this distance and the particle B and C, they collide already here. And now BC, I write BC together. I write BC and BC together. BC will move forward and go this way. Okay, students. So let's say it traveled some distance. Okay, it reach here. Let's say it reach here. Okay, and it travels. BC will travel how much from here till here? How much it travels? It travels X distance. Let's say I don't know exactly. X distance. All right, and um, X distance, okay. And now how much this distance left behind? You know it very well, students. So total is a 2.1, 2.1, 2.1. So 2.1 subtract 1.2. So it means this is becoming distance. How much is 0.9 meter? How come? From 2.1 subtract 1.2, I got 0.9 meter distance. I hope so got the idea. Now situation is what? And now it prepared this situation when it is here, this part, these two BC particle is here. Repeat. When A reach here, BC, look at it, I repeat again. Actually, in 2 seconds, 2 seconds, B reach here. Sure, B reach here. Okay. And become BC. And in 2 seconds, A reach here, which is a 0.9 meter far apart. It means when time is 2 seconds is done, BC is here and A is here. Now gap between them at that particular moment is zero point 0.9. Now here, now I want to see that this is a distance traveled by particle A, and this distance traveled by the BC particle. And make sure, and this gap between zero point 0.9 and time from here onward remains same. Why? Because can you imagine that particle A is here and BC here? From here, it will move this way and it will move this way. So same time they will travel to reach at this particular collision point. And now what I can do now, finally, I think I can make a plan. Can I say this distance, total distance is XA exactly, and distance traveled by BC is this one exactly equal to 0.9 meters? How come? Repeat. The distance traveled by A is total whatever, and distance by this one whatever. If it from full distance, if you subtract this distance, you will get this distance. I hope so, God. And what is distance formula? You know, because constant speeds are there, no frictions there. So S is equal to VT. So I'm writing VT here and VT here. But this VT for A and A velocity, what you know, after getting losing the velocity speed is 0.62 out of A particle. So 0.6 times to T, and what velocity of the together particle both is a combined velocity of the both particles. I think we have it here. 1 minute, please. After collision, BC, I think we got it here. Yeah, combined velocity of the both particles 0.5. So 0.5. So 0.5 times 2 T, okay, and 0.9. So this becomes a 0.1 time equal to 0.9, and time becomes what here? 0.9 by 0.1, and decimal cancel. 9 seconds it will take to reach there. So I hope so. This was a little bit hard, but I hope so. I tried my level best to explain the concept. Okay. And I hope so you got the idea very clear. It will take total how much time? 9 seconds, okay, to reach before the start collision till they hit. So these diagrams are very important to show, otherwise is the not easy to get it. And as just as a teacher, when you have these kind of questions come, please draw this kind of diagrams. Let's go for the next last question of this paper. P travel straight line and start from rest at O. So when time is 0, velocity is confirmed 0 and S is 0 because starting from rest. And he mentioned what here? This is for first 4 seconds and acceleration given. He said that find velocity when time is 4. So I'm bound to use first equation. A is equal to 0.3 t to power half. Integrating, you know, there was a rule we have, three levels are there, distance or displacement, then velocity, and then I get an acceleration. When I differentiate, I go up. When I want to come down, to integrate and integrate. So that is why you can see here that I am on the level of acceleration and I need velocity. So while coming down from top to this one, so I will do what, student? I will integrate it. So let's start. So integrating both sides, so I get velocity integral sine 0.3 t to the power half t and dt must be there. Increase the power by 1, I got a 3 by 2 and over 3 by 2 and plus c. And if you type this in calculator, it is will, and I know that it will flip, so becomes 0.2 t to power 3 by 2 plus c. But now I plug in the data, what data given, when time zero, velocity is zero, I plug in here. So put time zero, velocity is zero. When I plug in velocity is zero and time zero here, so I get C0. And finally, if it finally I got what velocity? 0.2 time to power 3 by 2. Now I plug in 4. So put time is equal to 4. When I plug in 4, velocity equal to 0.2 and 4 to power 3 by 2. If I type in calculator, so answer is coming with me is 1.6 meter per second. I hope so the point is clear. Next part, it's given that the no change in velocity when time is 4, at p time is 4, it means that time 4 velocity is what we know that velocity is this 1.6 is at 4. All right, it means we got a one pair, time 4 velocity 1.6, he mentions here. And second velocity is 116 when time is, time is 16, next data, and velocity is 0.3, second data given by him. Why given two data? Because when I will integrate this question, I'll get a C and I got a K and two unknown constant. That is why. They show that K must be 2.6, an expression for the velocity I'm looking for. So first of all, because he said 4 to T, so I'm bound to use second equation. First equation I can't use. So A equal to negative K T to power negative 3 by 2. So job number one, because of acceleration, I will integrate velocity and integral sine minus k t to the power 3 by 2 negative nt. And now I can do it, increase the power by 1. When I add 1, I get a negative half. Same negative half down and plus c1 to make a difference from the previous. The negative cancel, this 2 goes up and I got a 2k and this comes down, become positive half. Half is called root. If you don't write root, no issue at all. Okay, anyway, now I'll use this data. I'm saying put time is equal to 4, velocity is 16. First pair of values, not 16, 1.6, sorry. Okay. 1.6 and 2k over 4 root plus c. 4 root is 2. This cancel out. And I got k plus c equal to 1.6. Equation number 1 done. Now I'm using second data. Second data is time 16 and velocity is 0.3. When I plug in here, so 0.3 equal to 2k over root 16 plus c. So this is becoming 0.3 and this is becoming root 64. I got a half k. So multiply into 2 throughout. So I got a half into 2. This 2 cancel. I got a k into 2. I got 2c and into 2 I got 0.6. So I got equation number 2. And if I use it here, k plus 2c equal to 0.6. So naturally this is sign changes. This cancel out. I get negative c, and here I got negative, oh sorry, plus 1. And ultimately c become 1. And this c value I can plug in any one equation. If I plug in here, c1 here, and 1 goes, the k value becoming 0.6. Let me recheck. Sorry, c value is minus 1, not a 1. This minus 1, if it here goes there, and k value becoming 2.6, and which he was asking us to prove. but we have to find expression because he's asking expression of velocity. Finally, we need it. So both value plug in back in equation. So V equal to 2.6 into 2, 5.2 over root t n minus 1. So this is finally I got expression for velocity. Okay, so let's go for C part. P comes to rest at time is t and exact value t I'm looking for. Rest means very clear velocity is zero. So what I will use, I will plug in here velocity is zero. Here velocity is zero. When I have zero, plug in here 5.2 over root t minus 1. So 1 goes there, it becomes this. Root t multiplies there, it becomes this. And squaring both sides, and I got a time. And I got a time, if you square 5.2, square it. So it is giving me 27.04. 27.04 is my again. But is the question? Yeah, exactly. He was asking. This I got it. Exact value. Okay, or yeah. Now he's asking distance traveled from 0 to t till last moment. Okay, so there are two stages are there. First 0 to 4, and then 2 to. So if I want distance here is not a hard job. We need expression for first expression. We have it here. Where's expression? This expression of velocity I have it. If I integrate it because students, if I have velocity, I need distance, so I will integrate once again. So I think point is very clear, valid. So it means this. So first of all, I will integrate this to 0 to 4 limit. I will get distance. And then I will use second expression, which is here in the bottom here. Okay. And starting time is 4. Ending is capital T, which is I just got it now 27.04. So distance is very clear 0 to, sorry, I have 2 and this is a 4 to 27.04 and this is 0 to 4 and now I'm bringing the equations. So this equation is very clear, 5.2 over root t and minus 1 dt, whereas the first equation where expression I got it is 0.2 e to power 3 by 2 and dt must. Now I'm going to integrate, and what is the rule? Increase the power by 1 divided by same and 0 to 4 limit. And what is this one? Can I do it directly? No, first I bring it up. So it will become t to power negative half plus, sorry, minus 1. Increase the power by 1. So 5.2. If I add 1, I got a half down, and t comes here. And 4 till 27.04. And now I'm fine, but simplify first of all. So you know it very well, students. So this is the 0.2 into 0.4 divided by 5. It's becoming this the fraction form is coming to over 25. It makes question easier and less chance of mistake. 5.2 divided by half or divided by same thing half. Okay, 0.5 is coming 52 by 5 and time to root of t. Okay, now I'm plugging the values. When I plug in 2 divided by 25 into 4 to power 5 or 2, it's giving me 2.56. Resistance is coming with us 2.56. And when I plug in 0, 2.56. Correct. And then I will plug in here minus 0. Now I'm plugging this 27 by in fourth value. So let's start. 52 divided by 5 times 2, root of 27.04. And this answer and minus 27.04. So my first answer 676 over 25. I plug in every place. And minus now replace 4. When I replace 4, 52 divided by 5 into 2 and minus 4. It is giving me 84 over 5. And finally, 2.56 plus 676 by 25 minus 84 divided by 5. And answer is coming finally with us 12.8 meters. So I hope so. The concept is very clear. Alhamdulillah Rabbil Alameen. Exam paper is completely over. So best of luck for exams and pray for me. Assalamu alaikum wa rahmatullahi wa barakatuh.